Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of direct variation. This is standard A.2D in the great state of Texas, and we are using item number 10 of the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have the value of y varies directly. All right, so that is going to be our clue that we are using direct variation. If we look on our reference materials, you're going to see this formula, y equals kx. Sometimes you will get a word problem and it might say directly proportional. That's another way of saying it. It's direct variation, varies directly proportional. It's that word directly that kind of gives you a clue that we are dealing with direct variation. So what is direct variation? Well, direct variation, right, is going to look similar to slope-intercept form. That's something we're very familiar with. So we have in both of these cases, right, your y is going to be your dependent variable, and they give us our x's and y's in this particular problem. And then you've got your x, which is going to be your independent variable. That's how you start the problem. With your independent variable, you do something with it, you multiply it by something, which happens to be your k or your m. So both of those are going to be the same. You can think of them as the slope. You can think of them as the constant rate of change. And so you notice the only thing that's going to be different between these two is that b. This is the y-intercept, and we just don't have a y-intercept when we are looking at our direct variation. So the y-intercept just pushes the graph, this is a linear function, off the origin. So direct variation is always going to go right through the origin. The y-intercept is going to either push it up, down, left, or right. So how does that help us? Well, we need to find, we've got the x and the y. You're looking for the constant of proportionality. They used to give you that as a formula, but we don't really need it. If we want to isolate that k, right, we just divide both sides by x, and there we go. We've isolated the k. So k equals y over x. So let's just use what they give us. All right. So 21 over 3. So that's 7. So the constant is 7. So now, what is the value of x when y equals 105? Okay, so in this case, right, they are looking for your x, which is your independent variable. They're going to give you the y, and you had to figure out the k. So the y is the 105, right? That is our, remember, our dependent variable. So that just means we have an extra step over here. So I'm going to substitute in this y for the 105. We determined that the k is 7, and it's 7x. So as you can see, we're close. We only have one more step. We need to divide both sides by 7, and then we will get our x. We could use the calculator. Let's pretend like we are in 4th grade again, and we are doing long division. Always good to practice that in case you ever have to do it without a calculator or without your phone. So 7 doesn't go into 1. 7 does go into 10 one time. So we divide, and then we multiply. And then 1 times 7 is 7. We subtract. 10 minus 7 is 3. We check to make sure the 3 is smaller than our divisor. It is. And then we bring down 1 digit at a time, divide again, goes in 5 times, multiply again, subtract, nothing left over, there's no remainder, and it's just a simple 15. So when y is 105, our x is going to be 15. Our answer is J.